Professor Bob Young here. In this video, we're going to look at arithmetic operations on functions. So in this instructional video, we're going to add, subtract, multiply, and divide functions. And notice we're just naming the two functions f and g. Then all the values for x, for which both f of x and g of x are defined, are as follows. Now, I've got a thing I like to tell students. There's a bad way to write these operators, and there's a good way. Now, the bad way, and I'm going to put bad right above this, f plus g, f minus g, f times g. This is how the third one's pronounced here, f times g of x, and f divided by g of x. Now, that's all bad ways. You'll see textbooks write them. And right here on the left in this column, more bad. Bad, bad, bad. So they'll write f plus g in parentheses of x, f minus g of x, f times. But the best way to write them, and I'm going to come over here in this column with the green, this is good. So write your functions when you're adding, subtracting, multiplying, and dividing like this: f of x plus g of x, f of x minus g of x, f of x times g of x, and f of x divided by g of x, and so forth, and life will be good. Now notice the condition g of x can't be 0. Now let me back up here. Notice this last one, the denominator of a fraction, of course, can't be 0 in that form. So it says the condition g of x cannot equal 0, and the definition of the quotient means the domain of f divided by g of x is restricted to all values of x for which g of x is not 0. The condition does not mean that g of x is a function that is never 0. So sometimes you have to watch out for the way things are written and so forth. So be careful. You know, they may have on the bottom g of x plus 1 or something, and if that comes out 0, your fraction's not undefined. So we're going to go ahead now and use some operations on functions. Let's say we're given f of x equals x squared plus 1. Now, y'all know what that would be, a graph of a parabola shifted 1 unit which way? Vertically up 1. I was just seeing if you remember previous lessons. G of x is given as 3x plus 5. It would be a line in slope-intercept form. Now what they want us to do is evaluate f plus g of 1. Now notice they put a number in here for x. They put a 1 in here for x, and they wrote it the bad way. So we're going to go down here, and we're going to go ahead and plug this in, and we're going to write it the good way. So f of 1 plus g of 1 will help you add these two functions together, putting in that value of 1. Now, remember, we evaluated functions before, so we're just going to go ahead under here, find f of 1. So wherever we see an x, and we're locking in our x's, we're going to put in 1. So 1 squared plus 1 would give us this 2 value here. G of 1 would equal 3 times 1 plus 5. 3 plus 5 would be 8, so g of 1 is 8. So when you add these two functions up, substituting 1 in for x, you're going to get the final answer of 10. So the first few examples here, we're just going to take some functions and plug in some numbers, and when you plug in numbers, you get numbers back. All right, part B, f of x equals x squared plus 1, g of x, 3x plus 5. We're going to subtract the two functions, again, writing it the bad way, and say f minus g of negative 3. And notice this is the bad way to write it. So we're going to take and write it the good way, f of negative 3 minus g of negative 3. Okay, so we're just going to go up here for x under the f function, and wherever we see an x, we're going to put in negative 3. Show those steps. So negative 3 squared is a positive 9 plus 1. So f of negative 3 is 10. G of negative 3 is 3 times negative 3 plus 5. So that would give us a negative 9 plus 5. We would get a negative 4. Now here's where students have to be careful. When you're subtracting functions, the old minus a negative. So you've got f of negative 3 minus g of negative 3. So watch those signs. If g comes out negative, it's the same thing as adding here, and you'll get 14. So sign errors still in play. Multiplying, same functions. We're going to put 5 in here, and again, they write it the bad way. We're going to write it the good way. F of 5 times g of 5. So again, we're just plugging in values of x here. This might be one of those videos y'all can just fly through. I don't know. And we'll get 5 squared is 25 plus 1, or 26. I left a little gap in that one. G of 5 is 3 times 5 plus 5 is 15 plus 5 is 20. And I believe if you multiply those two together, you will get an answer of 520. Yes, I'm going to put some of these on the test if y'all want them. All right. Now, here's what I meant by that earlier statement, that g of 0 here does not necessarily have to come out 0 and make this fraction undefined. See, because we're dividing here, and again, they wrote it the bad way, f divided by g of 0, bad, and we wrote it the good way, f of 0 divided by g of 0. So we're just going to go ahead and plug 0 in here for x, which will give us 0 squared plus 1. So f of 0 is 1. G of 0 would be 3 times 0 plus 5. So g of 0 is 5. So this would not be an undefined fraction. It would come out the answer 1/5. Now let's do one where, or several examples now, where we don't get number answers, but we get polynomial answers. So I just created a few different functions here, and I said f of x now is 3x squared minus 4x plus 1, which hopefully you remember would be a parabola. And g of x is 5x minus 9, which would be a line. Now, part A, we're going to find f plus g of x, and again, they don't really write it in the good way, so I'm going to write f of x plus g of x. And then I can just go ahead and substitute in what those two things are. So f of x would be 3x squared minus 4x plus 1. And I'm going to put parentheses around that. Plus g of x would be 5x minus 9. I just like to use those parentheses to separate. Now I know what some of you are saying, Young. If you just put parentheses on there, you really don't need them. I mean, because when you add polynomials, you can just drop off the parentheses, which is true. Because when you distribute through, there's a 1 in front of each parenthesis. So we're just going to collect like terms here. And we're going to end up with 3x squared. Let's underline the x values here. A minus 4x plus 5x would be a plus 1x. And then I just like to use colors here when I'm collecting like terms. And then what? A 1 minus 9 would give us a minus 8. So in this case, we added polynomials. We said, what's f of x plus g of x? No number substituted in there, and we got a polynomial value. Okay? Part B. We're going to say f of x, write it the good way, minus g of x. So not much more here. Yes, I know you want some of these on the test. I'll put them on there. A lot of students like these, adding and subtracting, multiplying and dividing the functions. Okay, now this one's a little dangerous. And I think some of you may see why, and we've talked about this. Whenever you subtract fractions, oh, you don't know how many students forget to distribute that minus sign through. So I can do it in red here, and you don't know how many times this sign right here is missed. All right, so be very careful on these. So now when we collect like terms, we're going to end up with 3x squared, okay? And then I'll go ahead and underline the x values, minus 4x, minus 5x. So we end up with a minus 9x, and I'm trying to keep my colors going here. So that looks pretty good. And then plus 10 if we underline the numbers. So adding and subtracting, not bad. I don't care if you put numbers in there or just do it with polynomials. What's this multiplying, you say? Why not? Let's go ahead and take a few here. Now again, writing it the bad way. So we're going to write this the good way, f of x times g of x. Now, it doesn't matter which way you multiply two polynomials here, but I'll just go ahead and, well, I just made a few different functions up top there. And for f of x, I called it 4x squared minus 3. And g of x is now 2x plus 5. So they'll change the functions around on you. Now, how do you multiply these creatures? You may remember back, our friend FOIL is back. So foiling these, we will get first two terms, 8x cubed. The outside 2 would be plus 20x squared. The inside 2 would be minus 6x. And the last 2 would be minus 15. Dividing part D the good way, notice there were no like terms to collect on that one. We'll say f of x divided by g of x. Well, all I can do on this one is say 4x squared minus 3 over 2x plus 5, and that's the answer for that one, believe it or not. I mean, you could long divide. Some students ask me, do we need to long divide or synthetic divide and simplify that? Unless the top factors perfectly and the bottom cancels, the answer is no. That's how they leave it. So for part E, if you want to go ahead now and say f divided by g of negative 1, so I kind of tied that in, we'll write that the good way here. F of negative 1 divided by g of negative 1. We're just going to take this, and wherever we see an x, put in, you know what, negative 1. So let me go ahead and lock those in. And we're going to get 4 times negative 1 squared minus 3 over 2 times negative 1 plus 5. So the top, we get negative 1 squared is positive 1 times 4 is 4 minus 3 over the bottom is negative 2 plus 5. So part E ends up the answer 1/3. So again, when you use polynomials and you're adding, subtracting, multiplying, and dividing, you get polynomial answers. When substituting numbers, you get numerical answers. And here's a few more just for fun. I'm just changing the functions around here. So I let f of x be 8x minus 9, g of x be the square root of 2x minus 1. Adding them, here's what we get. I mean, this final answer here, because unless you have some other like radicals, you can't combine like terms and radicals. So this answer right here, f of x plus g of x. Same two functions, if you subtract them, not much happening. I mean, you've got f of x is the 8x minus 9. We're just putting a minus sign in there. Square root of 2x minus 1. Multiplying them, not too much difference. We just put the 8x minus 9 times the square root of 2x minus 1. Now, yes, you could distribute this one if you wanted. You may see some textbooks write this like this. 8x times that square root minus 9 times that square root. But I think if they're going to leave it like that on top, it looks a lot better. And dividing, well, there you go. I mean, with square roots in there, if there's nothing to combine, it's not too bad. Now let's talk domains again for a while here on this adding, subtracting, multiplying, and dividing. It says the domain of all these include the real numbers in the intersections of the domains of f and g, while the domain of f divided by g includes those real numbers in the intersection of the domains of f and g for which g of x is not 0. Now, I know some of you look at these and you go, Excuse me. Young's got a little bug while I'm doing this video. If you can't tell out there, I think I got a little something going on here, but I'm going to go ahead and fight through it. Now, intersections mean what things have in common. And some of you on intersections from intermediate algebra may remember that symbol that looks like the upside down horseshoe. So it means what two items have in common, or what, something like that. So keep that in mind. So for these functions we've been looking at, the ones we've just been really quickly doing, adding, subtracting, multiplying, and dividing, hopefully you know f of x is the graph of a line. And it says down there on the bottom, the domain of the graph of most lines, as we've looked at, the x values, if we graph most lines, is negative infinity to infinity. And g of x being a square root, now remember, underneath the radical can never be zero, or I'm sorry, not zero, but negative. So, of course, you can have the square root of 0 and get 0. So what we're doing is we're taking what's under the radical, and we're saying whatever's under there must be greater than or equal to 0. And if we solve for x here, which it doesn't look like we have here, let's show the steps. We'll add 1 to both sides, and you never thought we'd see these inequalities again. Divide by 2. So notice the x values would be greater than or equal to 1/2, and the domain of g of x is, in interval notation, 1/2 to infinity. Now, why the bracket? Includes. All right, so if we're looking at these two functions, if we add and subtract and we multiply them, and you can go back and look at those if you want to, and that's the beauty of this, you can rewind, fast forward, pause, whatever. The intersection of the set of real numbers and from 1/2 to infinity is 1/2 to infinity. So that would be the domain of the sum, difference, and product of those two functions. And finally, if we look at the division part here, we said that if we divided these two functions, that f divided by g would be 8x minus 9 over the square root of 2x minus 1. So now we have to have, there's a couple things happening here. We have to have numbers. We can't say greater than or equal to 1/2 here. See, because if it equals 1/2 on this division problem, then the denominator is the forbidden 0. So notice in this one, we have to just say it's 1/2 to infinity, not including the 1/2. All right, so I hope this was a good video presentation for you. I'm a little sick here, but I'm going to fight on and try to do the rest of Chapter 2 this morning. Professor Bob Young signing off. Have a good one.